um, period of attempting to fix our issues. Let's just quickly see whether everything is working correctly. This is Łukasz Biały from Virtus Lab, Scala developer advocate, and with me is Marek Nelken from Scala Specialty.
Yep. Hello.
Hello, everyone.
Nice.
And I hope everything is working correctly now for everyone. So we started before, but we will go from the beginning. And first question, Marek, would be who you actually are. So what is your background and what do you deal with? What is the business you're in?
Yes. Okay. So my background is I've been a computer programmer for all my career, studied computer science at university, and for the majority of the time I've been working, it's been in financial services, which is obviously kind of like the big thing in the UK and London. I initially started off in high frequency trading, which was quite an interesting sort of technical challenge. I think it's a bit less relevant these days, perhaps, but it was a good way to learn to vote the ropes. Then I set up with a friend an insurtech company trying to solve some of the data problems in insurance. And insurance is great because there's lots of data problems. So it's got a rich seam for getting into. And so then subsequent to that, I got involved and we set up, been going back just over 4 years now. Actually, it's probably almost 5, actually, CuraTech Specialty. So CuraTech Specialty has a very special meaning in American insurance, but essentially we are what's called a managing general agent, and we do the underwriting for insurance companies. So the general idea is you've got a big insurance company, they've got large amounts of money, but they may not have all the staff or the special skills to do the type of to cover every area, and we provide that service to them. It's kind of, I think one of the things it's always difficult to explain to people, at least people have got preconceptions about insurance because everyone buys personal insurance. Personal insurance is kind of like these days, it's kind of like a big data problem. It's, you go online, you put in, let's say you get covering your car, you put in your details and you get a quote back in seconds. And yes, but there's so much information available around this stuff that you can build those models. So although specialty doesn't quite refer to what we're doing, we do much more complex, higher value things. So rather than insuring, say, your house or your car, it might be insuring your factory or like a mall of shops and things like that. And there's just less information. You need kind of more human interaction with it. So you've got a problem, you need a lot more human in the loop, but you've also got quite a lot more information to sort of to deal with at the same time. So it's kind of, that's the challenge that we have as a business.
Okay. I wanted to quickly explain how this happened, because you are obviously a Scala programmer. You wouldn't be on this stream otherwise. But I wanted to make a recollection how we met, because Marek is working with Virtus Lab, and our first meet was when I was asked as principal software engineer at the time to take a look at the project that you brought, that you wanted to work on with us. And there was a thing that you said that really, it was an eye-opener for me, because my background is actually mostly distributed systems and functional programming. So I do a lot of stuff with Akka. I do a lot of complex programs. Basically, that boils down to that. And you said something that was really, really mind-blowing for me, that you are building business from ground up using Scala, because it's just that simple and productive. So I would like to talk about that. So you built CuraTech Specialty from the ground up. You were the founder. You were the first programmer in the project, right?
Yes, personally programmer. So the rest of the team are insurance specialists. I mean, I've got some more of insurance specialism over time, but yeah, I'm very much the programmer. The model that we've got I think is quite rare in insurance. It's not rare in other things like banking, for example, where you have like the quants, the people doing the math side, and then they team up with the programmers and they build platforms and trading systems. And that's my previous experience. So it was something I was used to, but it's something that doesn't really exist in insurance. And I think that's largely, there's a lot of smart people in insurance, especially highly mathematically trained. but they're not on the actuarial side. So they solve problems mathematically rather than from a computer programming point of view. And so I think as a result, we've kind of, insurance is a bit behind in terms of just tech generally. So you kind of like, you got less to catch up with. So it's a bit of an easier job, say, than it would be in other industries. And so the way we ended up doing this, I hadn't actually initially planned to build our platform. We were looked at buying in outside software, and there's some reasonably good stuff out there, but the problem is that it all requires a lot of customization. It can be comparatively expensive, and then in terms of like the time to actually get to market, it's going to be, I judged it would be as quick or quicker to just build everything ourselves. And I think without, and this is the compliment to Scala basically, without having sort of I have previous lots of experience with Scala, without that knowledge that you can get things, from my perspective, can get things done quickly, I wouldn't have really attempted it. So, if it was a C++, which was my sort of initial sort of commercial language, yeah, I don't think this would have been a decision I would have made. But it is very much the functional programming aspects of Scala, I think, that allow the productivity that we've got.
Okay, so if I understand you correctly, the domain itself is hugely complex, and you are already in a niche part of this domain, which is even more complex. So I would like to talk about that, especially. As I mentioned before, you said in this first conversation we had that Scala is such a productive language for you because it's so simple, it's that simple to write code that just does the things that you need it to do. So I wanted to talk about how you tackle complexity, given that you have this already enormously complex domain. How do you budget for complexity when developing production software in Scala?
Yeah, that's a good question. So I think Scala itself is a complex enough language to learn, but once you've got over that, and to be fair, we wouldn't have done, although we're an American-based company, I'm obviously based in the UK. Scala is much more sort of, I've found, much bigger on the European side than the American side. So there's that. But having had a functional programming background, it's the ability to express. So most of what you're doing, at least what we're doing, is we're taking ideas that are expressed sort of either as simple Excel spreadsheets or sort of word descriptions and rules, and it's trying to embody them in code. And you can just do that quite clearly and quickly and concisely, essentially. So it's the conciseness, I think, that really gives the benefit. You've then got sort of the other problems of what tools do you use within that, and I think and how do you get to something working as quickly as possible. And there's an element of taking shortcuts and kind of like building up a lot of technical debt, which is kind of why we ended up sort of working with Virtus to sort of basically pay down some of that debt. But despite that cost, you can get to something working. At least we got to something working very, very quickly, and then it's a case of iterating from there to improve and add further features.
Okay, I wanted to expand a little bit on this. So how do you feel would using a tool that is simpler in its own side, language side, like Go, for instance? Go is very simple on the language side. Wouldn't that work well for your use case?
I mean, it's possible. So partly I don't know Go as well, and it's it kind of like feels like a more productive C in lots of ways, and that's good. It's the thing is, a lot of and this is kind of like where the sort of the mathematical side of insurance, I think, comes in, is that everyone thinks and talks about things as functions. They're mathematical functions. There's a risk input, there's a curve, and translating maths into code is, I wouldn't say it's trivial, but it's much clearer if you do it in a functional language, because maths is functions. Whereas the more procedural, or a lot of the advantages also, you were talking about distributed systems. So one of the things that's interesting about, because we don't have a big data problem, we have a small data problem. So lots of things that you can solve by having more power and more distribution, we don't really get a great deal of benefit from that. What we get is a benefit from expressivity, and that's the thing that Scala brings. Because Go is great for all sorts of kind of like message passing and things like that, but that's not our core problem. I think it probably is in other areas of insurance, but it's not. That's not the problem we have to deal with.
Okay, so on the other hand, most of the quants that I know and most of the mathematically inclined people tend to know Python. So there's a lot of ecosystem stuff like NumPy and scikit libraries in Python ecosystem that allow for working with mathematical concepts. Why wouldn't Python fit the bill for you?
So I think some people are producing solutions based around Python, and I think they're having a good degree of success. So I wouldn't discount it entirely. I think the problem, at least the problem with Python is it's a dynamic language. And the trouble with dynamic languages, at least from my perspective for productivity, is that you have to do a lot of testing. You have to build a lot of tests, a lot of things that are otherwise covered by the type system. And that, in my judgment, slows down productivity. There's also a kind of a problem with, and this is a kind of like having worked a lot with mathematicians and physicists, their approach to, and I think Python tooling around that is excellent for lots of things they want to do. R is also very popular in insurance as well. But the way the mathematicians think is they think about the numbers and the results. They're not thinking about the data flow, and so as a result, you end up with maybe with some like little bits of code all over the place, maybe some Excel spreadsheets tying things together. And it's all quite Heath Robinson, and people get good results, but you don't get an integrated system. And the real problem that in insurance is not that the individual systems themselves are bad, it's just the fact that they're not particularly linked up. So there's a lot of double keying and transferring information manually. And we've kind of our goal, and it seems like a trivial and silly surprising goal that is even a novelty, is that you only enter the data once and it's all in one place. But because there's such a degree of complexity and different things going on in the insurance underwriting process, achieving that, not really many people have achieved that, and we have. And I think that's because you can, with a type system and functional programming, you can reason about the whole data flow in a way that if you have to start thinking about what you're doing procedurally in something like Python or it just gets, the complexity actually gets bigger. From a programmer's point of view, it's kind of simpler for the mathematician, but less simple, I think, for the computer scientists.
Sure. So I'm already smiling because my next question is, it regards what are your tips about what is worth investing in when building product, from the start. What are the things that you have to focus on, and what are the things that are rather hindrances?
Yes, well, so this is interesting. I think a hindrance is having to learn anything, basically. So that's so I think you've got this kind of, from my perspective, a debate about what extra tooling to use, what new things. There's always some shiny new technology lots of it's all incredibly useful, but the time cost to learn it and evaluate it properly is larger than the time cost to just get something working. And you've already, Scala's quite batteries included, and you've also got all the Java ecosystem which you can put in libraries to do sort of utility things. And so, yeah, that's the kind of judgment that we made. And it's the same, say, for example, with our database choices. We just use Postgres. These days, you can get that in the clouds. You don't have to worry about backups and things like that. It provides everything we need. But then we've kind of had we're a bit of a hybrid we had a hybrid approach there, which was kind of like, we've got Postgres does the key sort of relational database bits, which you do need, especially because we're dealing with financial transactions. If you don't have that transactionality, then you get in a lot of trouble. But we kind of like shortcut that a bit by sticking everything in JSON. So you've kind of got a tree of tables, but all the actual content is in JSON, so it's much more flexible. Now I think the JSON thing is an interesting one, because JSON is the sort of, when you talk about, say, either using JavaScript or Python and things like that, you'd think, oh, actually they're the natural matches to that. So, but that then goes against the whole kind of like strongly typed system. So we ended up with basically a hybrid where it's strongly typed in the Scala domain, but it's basically untyped in the database, and that allows you to iterate quickly. So yeah, it's it's a case of kind of focusing on what's needed. And insurance itself is especially difficult for this. So schema changes. I mean, a classic example is if you imagine a bank account. If you've got a bank account, it's basically got the name, the number, and the transactions coming in and out, and that's not changed for hundreds or thousands of years. Insurance, although it's been around for just as long as banking, there's always a new piece of information you need to capture. So whether it's if you're underwriting a building, you need to know what it's made of. But someone might say, oh, but what kind of tiles were they, or when did they last replace this? And it's not in your data model. And so a lot of my day-to-day work is that the underwriting team say, we've either got an insight in the sense that we think it's more profitable if we gather this information, or we've been ordered to do it because someone up the chain has made the same decision. We need to capture that information now, and the kind of refactoring. If all of your data models is actually in SQL, it's just managing that is very difficult. Whereas if it's in JSON, it's we'll stick another field on it, and then you stick another field in the case class in Scala, and as long as you tie those things up, which obviously there's some work involved with that, you can iterate very quickly, and you can get the results that underwriters want. Whereas the kind of traditional model is insurance is that gets sent off to like some outsourced team. It'll be on the list. It'll take 6 months to get back, and by the time it's been finally implemented, things have moved on, and people end up. And this is where you end up with too many Excel spreadsheets. It's like, well, we can't get it into the system now, so let's have a spreadsheet where we record this information, and then you're back to spreadsheets again. So you can't make progress. So it's having that ability to iterate quickly is the key.
Okay, so famous Postgres is the best document database approach. I really dig that. So we mentioned that you prefer to stick with boring technologies, but you also mentioned that there's the benefit that you get from Scala because you are able to track the data flow. So that naturally kind of flows into whether you are using any fancy modeling stuff that Scala already provides. So what is the tech stack in your application?
So, I double checked SBT files for this. There's only one. It's not even. I don't know if it's fancy. It's good. It's great. Is MacWire, which we do for dependency injection. That was suggested by Versa's team. I was highly skeptical at the start because I was thinking, wait a second, we end up in a kind of Spring thing with annotations. It's like, no, we're not. It's great. But beyond that, there's everything is just pure Scala and the Scala standard library, and then just a handful of utility Java libraries. So the most obvious one is Jetty because it's a web app, as everything is these days. But this is one of the interesting things. I mean, I remember starting off with Scalatra, which was, I think, is great. But I remember the experience of doing that and building other things with it is that the number of, when you've got quite a wide functioning library, it will often cover an awful lot of what you want to do, except a handful of things. But the number of things you want to do is much smaller often than that library API surface. So it kind of becomes, if you've got to customize something anyway, you can kind of like quickly just knock everything up without expending the time to get into the libraries, even if maybe in the long run or overall they might be better in doing what you're doing, as long as you've covered all the minimum set of functionality that you need yourself. From my perspective, our perspective, it's not worth the time investment. So yeah, we've got PDF box, which is for handling PDFs, and Apache POI or whatever for Excel spreadsheets. I mean, they're the really sort of boring workaday things that no one's bothered writing Scala wrappers for them because it's not really relevant. So yeah, we just sort of skip that. But there's also, I think this is the great thing about Scala 3 is that I would have not made use of it before. In fact, I was even making use of code generation. We started off in Scala 2 before Scala 3 came out. Was actually had some sort of custom Scala build process that anyway did code generation to create some stuff from, I think, an XML spec. Anyway, instead of we actually did that manually, but then with the advent of the integration of macros into the language, we transferred to that. I mean, arguably might have been better off starting using one of the kind of the pre-existing macro libraries. But I've also got this kind of like fear of it's like if they're going to go obsolete, it's like you stick to what's in the language standard, because you're taking fewer risks with things not being supported later on.
Oh, okay. So let me get this clearly. You're not using basically any libraries from Scala ecosystem. If I may, that might be a touchy point for our colleagues in the ecosystem. But what do you find is the biggest problem with Scala libraries? Are they lacking in features or stability? What is the problem?
Well, I think it's actually probably the complete opposite. Well, there's one element is like there's from my perspective, despite having studied computer science, I still find quite a lot of the higher kind of type sort of structure within Scala itself challenging enough. And so having something that's even more sort of complex is something that it's just another thing to learn, and to get your head around. So that's the key problem. I don't think there's any problem with these things per se. And you also, I think there's a judgment. I mean, whether this is correct or not, it depends what the skill base is. The more complex library to use, the smaller the pool of people who can help you with it in the future are. So you might be cutting off, half of the available Scala developers if they're not specialists in one area. It's that kind of like cost judgment that's kind of driving it. Whereas, just writing stuff in servlets and wrapping them up in some simple bits of Scala, it's like pretty much everyone could understand that. Even a Java programmer could probably get started. Okay. Whereas,
that sounds reasonable actually, given the hiring pool sizes in comparison. That's reasonable. So so if you aren't really leveraging anything that is happening in the Scala ecosystem, you're basically just using the Stone library with one exception of the DI library.
Yeah.
So how does Scala bring value to your development? Why wouldn't you just, what would be the problem to just, if you're already using servlets, why wouldn't you just use Java to do this?
Well, yeah. So then that's the problem. So because it's a good question. I think now with some of the advances and functional improvements in Java, that judgment might be starting to change. You still got the whole problem. You don't have macros, and you don't have the meta programming in Java. Well, I mean, there are meta programming libraries, but nothing like what Scala has. So you lack the meta programming, which is immensely important for making things quick to develop. And Java is still very verbose, and it's not, you can't write pure functional stuff in it. It has some functional features now, but a lot of what when I'm sort of tasked with, here's a spreadsheet that's our model with, it's been approved, translate that into something that works. It's like it's just functions, and you can the pure functional aspect and the fact that it's exceptionally concise. You can pretty much put most of a pricing model in, like it would be one very long line of thing with lots of maps and folds and whatever. But you can express an enormous amount very, very quickly. So yeah, that's the benefit of Scala. But you've got because you can just bolt it onto all the really simple bog standard Java libraries, you take advantage of them without the downsides of Java.
Okay, you mentioned metaprogramming, that you are leveraging metaprogramming in Scala 3. Could we expand upon that? I mean, what is the problem? Why wouldn't you, for instance, use Java reflection to achieve the same thing? How does metaprogramming in Scala help you?
I mean, it's a good question. I mean, you could argue, well, I mean, you could get a lot of what we're doing done with reflection. I mean, I've got a general instinct that reflection's slow. I mean, it's compared to outputting code directly, which is effectively what you get with the macro system. I'm sort of suspicious of that. But then but it's also the lack of typing that you get with reflection. So a lot of what we're doing is serialization, deserialization, sort of iterating over members of case classes, which are all doable in with Java reflection. But you're then putting everything into the dynamic domain. So you don't know that's going to work until you get a type error thrown when you're running the code. Whereas if you with Scala, you've got it all within the type system. If the types don't match up, it won't compile. And now actually you get some reasonably helpful errors. It wasn't so helpful at the beginning, but actually it's getting a lot better. So the type system does an enormous amount of work for you, and that means that's a set of tests you don't have to write. So if you've got something that's doing reflection, I don't think it's very responsible or effective to not have some tests to check that everything was working, and that's much less doing your sort of like your CI process. Take a few minutes to run all your tests. Whereas with the compiler these days, you get a little underlined warning in your IDE just like that, and it's that's a real productivity gain.
Okay, since we're already on this red squiggle area, you have started building Curatech. I think it was 4 years ago.
Yeah, so I think actually it's 2019 we started. We didn't start writing code until the very end. So basically, beginning of 2020 was when we.
Was this already after Scala 3 was released?
No, so it was 2.13 something, I think. Yeah, it was what's really called old-fashioned Scala. I mean, there's the transition has been very smooth, I have to say, and I jumped on Scala 3 because of the macro features. Because, to be fair, there's not a great deal different in day-to-day use between 3 and 2, other than the fact that the meta programming is now part of it. I mean, over time, there's been some. Well, we've now got the new syntax and things like that. But I mean, it's nice, but it's not a make or break. I mean, having to put some extra curly brackets in isn't the end of the world. I mean, sure. Whereas having meta programming is almost vital, because we were doing meta programming effectively manually anyway. So.
Okay, so this next question, I'm a bit anxious about that, because at Virtuous Lab we are working at metals, and I know the state of everything in the tooling area, but I wanted to ask you about your journey with tooling, given how early you have started working with Scala 3. So right now, the situation from my perspective is bordering unacceptable, depending on how many fancy features you're using. I am myself a user of I would say pretty fancy stuff, and we try to push the type system in stuff that we do in the open source. I mean, to the maximum, to get maximum amount of benefits. But you were doing that, so you were already pushing the type system with metaprogramming facilities to the max in 2020, right? Late 2020.
Yes, well, it was hand built metaprogramming, but then it must have been like by about a year in, I think we moved to Scala 3.
What tools do you use? What tools
do
you use?
So in IntelliJ, I've got is basically the answer. I've had this long desire to sort of get metals up and working. So the two key downsides at the moment. Well, I think these things are changing. So one is that the database tooling in IntelliJ with Postgres it just works really well for me. So it's just kind of moving out of that environment is the equivalent stuff in what's the Microsoft anyway. Because metals is anyway. Microsoft do have a SQL tooling stuff that plugins, but it just doesn't quite hit that. And so far, at least, when IntelliJ has always been ahead in terms of like shortcuts and jumping, all of the kind of like sort of things that speed up, Control B to jump straight to the definition. It's always been just a little bit weaker in metals so far, and I haven't taken a look at it for a while. So, Alex, I know there's lots of interesting stuff with the incremental compiler. I think it's the partial tasty stuff, isn't it? Which looks cool.
But that's still in development, but yeah, it's coming, and it's hopefully going to bridge the gap, because I was going to say that I hope we are getting close to how well that works. It's easier given that with Scala 3, IntelliJ has some issues. So speaking about that, you were using IntelliJ for the whole time, like it's 3 years now, right? So you've seen the whole journey. How would you describe it? Is it a big problem for you that tooling has some, let's say, issues with Scala?
So not now. I think it's got an awful lot better. At the very beginning, IntelliJ was pretty useless. It's like the early sort of preview versions of the Scala 3 features. It's like it could accept the syntax, but I was basically recompiling everything, just less BT, and it was a bit of a mess. But it's got a lot better over time. I don't know if it's perfect yet. It seems now to have caught up basically with the language. So it's got all the features that it had before, but it's taken a while to get there. But yeah, I suppose I guess it's introspection in. I haven't actually tried this, so I don't know if it is possible. Like introspection inside macro code, I don't know how well that's supported. I've not really tried it. That will be the interesting thing. I'm sure the other the Versus guys working with have actually been trying that out, so I'll probably ask them. But if that will be the final sort of like winning piece, which might be there, but I don't know. I haven't tried it.
I mean, I'm trying to figure out if I can answer your question on the podcast, but to be perfectly honest, I don't remember what was the last time I used IntelliJ with macros. I gave up mostly because once you, well, the problem is IntelliJ has trouble typing results of macros. So where you apply macros, where you use macros, there's a lot of breakage there, and IntelliJ is unable to infer what the types are coming out of macros, especially transparent inline. So I did give up on that because in metals that just works. There's a lot of other stuff that is spotty to say.
Yeah.
But the things that we use a lot, which is metaprogramming facilities, I think they work better in metals. So I don't know. I should probably try IntelliJ with macro code, how it works now in the new versions.
Yeah, I mean it's interesting, but then there's an argument to say that if the BSP, all the that JSON language to explain the things, if that reaches parity with the features that IntelliJ has, then it's in IntelliJ's interest to just go straight for that. So hopefully there'll be a merging of feature parity at some point, and yeah, that would be the most logical, I guess.
Yeah, that's what we also hope, and we have some experiments around that, but that's material for another podcast, I think.
Yeah.
So getting back to tooling, there's IDE, that's the interface that you work with. What about other stuff? Did you find any things in Scala 3 that were troublesome for you when you were building your business?
No, I think is the answer. There's absolutely no issues at all. So I think one of the things that in terms of talking about high productivity is something actually I learned from the high frequency trading world, is that quick startup times to your code mean that you can do the edit test sort of cycle much more quickly, and when the compile, it was actually a bit more hassle when the compile was a bit slower, but there's been really good speed improvements with the sort of the incremental compilation. So you can just restart and load. So, but that requires a design approach from our side to make sure that there are very few delays in the getting Jetty spun up with enough stuff to be able to sort of press a button to double check that it looks right. It's not hard to do, but it's one of those things that if you don't plan for it at the beginning, you're not going to get there. So that, I think, cuts out the other issues. So I think, yeah, one of the things with sort of other systems outside of the JVM world have is the ability to sort of like edit and reload in a live system. That doesn't really work in the JVM, and Scala can't really fix that because it's an underlying sort of element. I mean, you can do the class reload things, but the class loading system is Byzantine, so it's never going to really be. It's not really a solvable problem. So the way to solve that problem is just have quick startup times, and that also solves deployment. So we've got incredibly simple deployment processes. Basically, a script that copies a jar via SCP to an empty Linux box which has got the JVM installed, and that's it. And so kind of all of that deployment infrastructure effectively we've got within our code system. So it's again, it's one of those simplifying measures. It's like I think if we were to try and service this as something we were sort of interested in, is like providing this as a solution to other sort of other insurance organizations, then that whole kind of deployment management thing would be something that would, I think, taking advantage of Docker and proper tooling would be a lot more sensible. But given that we've only got one instance running and I can press the scripts and deploy it, that solves our problems. So it's not something that we've focused on. And I think there's a lot of there's little shortcuts that if you add them all up, you don't create those delays. That if you come from a more like this is a big project, we want to do everything properly from the start, you build more tooling in. It probably has a longer term benefit, but it doesn't get you to something that works as quickly. And that was our priority.
Yeah, well, I'm offering the infrastructure as code library, so it kind of hurts my feelings, but I do understand the benefit of keeping things very simple at the start. So
yeah, I mean, and to be fair, like with our sort of like our CI infrastructure, that's all using not the various sort of tools that are available for making that work, which some of which are, I suppose our SBT configuration in terms of the tests and CI side does use a few
it's a bit more complex. True. Okay, I think that's basically that. So you mentioned before that you have this approach that you want to have results, usable, workable results, application that the user can use as fast as possible. And that means, in the end, that you have to cut some corners. So, yeah. Well, that is expected, I think, approach in the startups. I've seen a fair lot of startup code with things being commented out and just left, we'll fix that, in the future. So I imagine that this is how things look like, at least in the beginning when you are trying to get something really working for the customers that are waiting for your solution. How do you deal with that? How do you live with application that has all of that mess inside?
Well, so I think the answer is it doesn't work in the long run. That's why we sort of teamed up with Virtus to sort of basically, you could say it's pretty much go through every to-do and change it, but it's a bit more complex than that. The situation we got to is we got a working system doing everything we needed, and I had a sort of fairly clear idea of where it should get to, but we hit a level of sort of like time complexity in terms of I had the day-to-day sort of maintenance and sort of updating the business logic, consuming a lot of my time. And then there was a too much complexity for me to deal with to refactor out these issues. So it kind of just hit a point. Now, so I think the real advantage with Scala is that you can just the natural sort of functional approach lets you compartmentalize. You can keep in one person's head a more complex system in Scala than I think you can in Java or other sort of more procedural systems, because you can package things as function and you can reason about them. So yeah, but it hit a point where it's like, well, we're not making any progress now because it's too much for one person. So I think the value that Scala had, despite the fact there's always kind of very rushed written code, with holes missing and workarounds and things like that, is that because you can't avoid in Scala expressing things with a degree of typing and functional approach. It means it's actually, I think, a lot easier to refactor that code into something more sensible, because you can see a lot more of the intent and the structure and because of the type system. And it also means that sort of refactoring, this is one of the things for universities, you can treat a program as a proof and you can move things around. Because you've got those type constraints, it's a lot more efficient to do refactorings, because you don't need to cover as much assumptions, because you can actually see them in front of you written in quite concise code. So I think it was if I'd done the same thing in Java, let's say, I think we'd be in a lot more trouble. I think paying down that debt would be a lot harder, because it would require an awful lot more explanation as to what the intent was. But because it's in Scala, you can dig your way out of that hole much more quickly than I think in other languages. So that's another sort of plus point, I think.
Cool. I don't really have any more questions. I kind of hope that we would get some questions from our viewers, but I don't see any in the chats. So I have one last thing to ask you. What tips would you give to people who would like to build a business using Scala?
Well, the first thing is learn Scala. And that's tricky. So I think that a lot of the problem with this business is so in insurance, as I say, I'm in a unique position. I think if I was talking to sort of an audience of people in banking or maybe like retail, I think that would be a much more natural choice, because there's more computer people involved. In insurance, I'd say we're kind of the first. We're the first ones to do it, as far as I'm aware. So, I mean, I'd recommend it over anything else. But yeah, I think you could also argue I don't know enough about, say, F#, whatever. I've talked to people in banking who absolutely love it, and it's got a lot of those functional programming features. I'd actually say the recommendation would be do something, write your code in a functional style. Because Haskell as well, even, I think the trouble with something like Haskell is that you don't have the backup of all these like utilities. You don't have like all these Java jars you can just pull in to do utility work. And I think the Java ecosystem is arguably better than the .NET ecosystem in terms of just the breadth of like ordinary business things. So by that sort of default, if you say you've got Haskell, F# and Scala, well, Scala's the best bet, because you've got the backing of the entire Java ecosystem, which for enterprise software is just it's the biggest thing out there. And Scala's arguably the most advanced industrial functional language. So it's kind of like I'd say it's a no-brainer if you want to get there, get something quick and accurate. I think you can get something quick with lots of other languages, but the thing about Scala is you can make it accurate and you can refactor it later. So you can build up those costs, but you will be able to pay them down. Whereas I think it's much harder with other languages.
Well, thank you so much. I think that will be all. So
cool.
Thank you for coming. Thank you for sharing your knowledge and your experience
Thanks
with us. And thank you, viewers. We will see you together soon. Thank you. Bye.
Cool. Cheers.